Hello, good evening, students. I hope you all are fine. So now we will see an experiment. We will study some concepts about basic geotechnical engineering. I'm sharing the screen. I hope this is visible to you. Starting from module 1, define soil as three-phase system. So how we are defining soil as a three-phase system, we have to see. To define soil as a three-phase system. So the three-phase system consists of solid particles, water and air. That is V is equal to VA plus VW plus VS. So your soil as a three-phase system of soil we are considering. So this three-phase system consists of solid particles, water and air. V is equal to VA plus VW plus VS. That is total volume V is equal to volume of air plus volume of water plus volume of solids. So water Atterberg limits. Atterberg divided the soil into four stages. Number one was liquid state, number two was plastic state, number three was semi-solid state, number four was solid state. Atterberg set the arbitrary limits for these four stages as consistency limit or arbitrary limits. So now we need to understand what we mean by bulk density and dry density of soil. Bulk density of soil rho is equal to mass of soil by volume of soil. It is equal to m by v, and in SI unit is kg per meter cube. Next, dry density of soil, how we are defining dry mass of soil to volume of soil, md by v. So the SI unit is kg per meter cube. Next, define water content and voids ratio. So how you define water content? Weight of water by weight of solids expressed as a percentage. So W is equal to WW by WD into 100, or voids ratio is equal to EVV by VS. So define specific gravity and unit weight of soil. The specific gravity of soil G is equal to gamma S by gamma W, and unit weight of soil gamma S is equal to WD by VS. So define density index. The density index is defined as the ratio of difference between the voids of the soil in its loosest state, Emax, and its natural voids ratio E to the difference between the voids ratio in the loosest and densest state. So now define honeycomb and flocculent. How we are defining honeycomb and flocculent? Honeycomb is an arrangement of soil particles having a comparatively loose, stable structure resembling a honeycomb. An arrangement composed of flocks of soil particles instead of individual soil particle is known as flocculent structure. Define kaolinite and montmorillonite. Kaolinite structure unit is made up of gibbsite sheets joined to silica sheets through the unbalanced oxygen atoms at the apexes of the silica. Montmorillonite is the most common clay minerals in expansive clay soil. The mineral is made of sheets like units. So now we need to define compaction. So how you define compaction? Compaction is a process in which the soil particles are artificially rearranged and packed together into a closer state of contact by mechanical means in order to decrease the porosity of the soil and thus increases its dry density. So how we are defining compaction? Compaction क्या है? Compaction एक ऐसा प्रोसेस है जिसमें क्या हो रहा है, soil particles artificially rearranged and packed together into a closer state of contact. Compaction is a process in which the soil particles are artificially rearranged and packed together into a closer state of contact by mechanical means in order to decrease the porosity of the soil and thus increases its dry density. तो कॉम्पेक्शन क्या है? एक ऐसा प्रोसेस है जिसमें सॉइल पार्टिकल्स आर्टिफिशियली रीअरेंज्ड हैं, हम अरेंज कर रहे हैं सॉइल पार्टिकल्स को and packed together into a closer state of contact by mechanical means in order to decrease the porosity of the soil and thus increase its dry density. इसमें क्या हो रहा? पोरेसिटी कम हो रही, वॉल रेशियो कम हो रही, इंक्रीज क्या हो रहा? ड्राई डेंसिटी. What are the factors affecting compaction? Factors affecting compaction are water content, amount and type of compaction, type of soil, addition of admixtures. So now define zero airwords line. A line which shows the water content, dry density relation for the compacted soil containing a constant percentage air voids is known as your zero air voids line. So क्या है zero air voids line? एक ऐसी लाइन जो कि बताती है आपका वाटर कंटेंट, ड्राई डेंसिटी का रिलेशन फॉर द कॉम्पैक्टेड सॉइल containing a constant percentage air voids is known as zero air void line. Differentiate disperse and coarse grain skeleton structure. Disperse is an arrangement composed of particles have particles having face to face or parallel orientation. Disperse क्या है? एक ऐसा arrangement है. Disperse is an arrangement composed of particles having a face to face or parallel orientation. Coarse grain skeleton is an arrangement of coarse grains forming a skeleton with its interstices particles filled by a relatively loose aggregation of finest soil grains. So module 3, what do you mean by Darcy's law? Darcy's law states that the rate of flow or discharge per unit time is proportional to the hydraulic gradient in the laminar flow condition in a saturated soil. So Darcy's law क्या है? Darcy's law states that the rate of flow or discharge per unit time is proportional to the hydraulic gradient in the laminar flow condition in a saturated soil. So define superficial velocity and coefficient of percolation. Superficial velocity Vd is equal to Q by A. Coefficient of percolation is the seepage velocity is proportional to the hydraulic gradient. So define permeability and coefficient of permeability. So how we are defining permeability? Permeability is defined as seepage of water to soil soil. Permeability is defined as seepage of water to soil. Coefficient of permeability is defined as the average velocity of flow that will occur through the total cross-sectional area of soil under unit hydraulic gradient. Permeability या coefficient of permeability. Permeability क्या है? Permeability is defined as seepage of water to the soil, whereas coefficient of permeability is defined as average velocity of flow that will occur through the total cross-sectional area of soil under unit hydraulic gradient. Define discharge velocity and seepage velocity. Discharge velocity Vd is equal to Q by A. Seepage velocity Vs is equal to Q by Av. So what are the factors affecting permeability? The factors affecting permeability are grain size, properties of the pore fluid, voids ratio of the soil, and structural arrangement of soil particle. Once again, define discharge velocity and seepage velocity. How you will define or differentiate between discharge velocity and seepage velocity? Discharge velocity Vd is equal to Q by A, discharge per unit area. where a seepage velocity is Q by AV, area Q by AV. What are the factors affecting permeability? The factors affecting permeability are grain size. ग्रेन का जो साइज है वो इफेक्ट करता है परमेबिलिटी को। नेक्स्ट, प्रॉपर्टीज ऑफ द पोर फ्लूइड। जो पोर फ्लूइड है उसके प्रॉपर्टीज से भी परमेबिलिटी इफेक्ट होती है। वॉइड्स रेशियो ऑफ द सॉइल। वॉइड्स रेशियो क्या है सॉइल का, दैट आल्सो इफेक्ट द परमेबिलिटी। स्ट्रक्चरल अरेंजमेंट ऑफ सॉइल पार्टिकल्स। जो सॉइल पार्टिकल्स हैं उसको कैसा अरेंज करें वो भी डिपेंड करता है परमेबिलिटी पे। Define shear strength of soil. Shear strength of soil is the resistance to deformation by continuous shear displacement of soil particles by the action of shear stress. Shear strength of soil क्या है? Shear strength of soil is the resistance to deformation by continuous shear displacement of soil particle by the action of shear stress. Shear strength of soil क्या है? Shear strength of soil is the resistance to deformation by continuous shear displacement of soil particles by the action of shear stress. Define thixotrophy and sensitivity. The phenomena of strength loss or strength gain with the change in volume or water is known as thixotrophy. How you are defining, and here we are defining thixotrophy, द फिनोमिना ऑफ स्ट्रेंथ लॉस। जो स्ट्रेंथ लॉस होती है वो या फिर स्ट्रेंथ गेन होती है वो विथ नो चेंज इन वॉल्यूम, लेकिन वॉल्यूम चेंज नहीं हो रहा। द फिनोमिना ऑफ स्ट्रेंथ लॉस और स्ट्रेंथ गेन विथ नो चेंज इन वॉल्यूम और वाटर इज नोन एज थिक्सोट्रॉफी। Not is sensitivity. Sensitivity is the ratio of unconfined compression strength in the natural or undisturbed state to that in remolded state without change in water. So the phenomena of strength loss or strength gain with no change in volume or water is known as thixotrophy. Thixotrophy क्या है? ऐसा फिनोमिना जिसमें स्ट्रेंथ लॉस भी नहीं हो रही, स्ट्रेंथ गेन भी नहीं हो रही, with no change in volume or water is known as thixotrophy. Sensitivity क्या है? Sensitivity is the ratio of unconfined compression strength in the normal or undisturbed state to that in remolded state. To that in remolded state. I guess we have lost the connection. I am sharing the screen once again. You just tell me whether it is visible to you or not. S- What are the factors affecting shear strength of soil? So, what are the factors that affect shear strength of soil? The factors affecting shear strength of soil are soil composition. इस तरीके की है soil, उसका composition क्या है? Soil composition. Next, initial state of soil कैसा है? That also affect the shear strength of soil. Then structure. How is the structure of this soil? It also affects the shear strength. What are the laboratory methods to determine shearing resistance of soil? The laboratory methods to determine shearing strength of soil are direct shear test, triaxial shear test, unconfined compression test, vane shear test. क्या क्या laboratory methods हैं to determine shear strength of soil? Direct shear test, triaxial shear test, unconfined compression test, and vane shear test. So what are the different types of shear test based on drainage condition? तो ये लेबोरेटरी मेथड से डिटरमाइन करने के शेयर रेजिस्टेंस ऑफ सॉइल कौन से डायरेक्ट शेयर टेस्ट, ट्राइएक्सियल शेयर टेस्ट, अनकन्फाइंड कंप्रेशन टेस्ट एंड वेन शेयर टेस्ट। नेक्स्ट, व्हाट आर द डिफरेंट टाइप्स ऑफ शेयर टेस्ट बेस्ड ऑन ड्रेनेज कंडीशन? ड्रेनेज कंडीशन के हिसाब से कौन से टेस्ट हैं? द डिफरेंट टाइप्स ऑफ शेयर टेस्ट बेस्ड ऑन ड्रेनेज कंडीशन आर undrained test or quick test, consolidated undrained test, and drain test. Next is consolidation. How you will define consolidation? A compression resulting from a long-term static load and the consequent escape of pore water is known as consolidation. क्या है consolidation? A compression resulting from a long-term static load and the consequent escape of pore water is known as consolidation. So what are the assumptions made in Terziki's theory? The assumptions made in Terziki's theory are the soil is homogeneous and fully saturated. The soil particle and water are incompressible. First assumption is the assumption made in Terzikian as the soil is homogeneous and fully saturated. Next, the soil particles and water are incompressible. Define coefficient of compressibility and coefficient of volume change. Coefficient of compressibility AY is equal to minus delta E by delta sigma, whereas coefficient of volume change MV is defined as change in volume of a soil per unit of initial volume due to given unit increase in the pressure. So what are the methods to find consolidation settlement? The consolidation settlement can be computed by two methods. Method one using coefficient of volume change. Number two using Voigt's ratio. So define primary and secondary consolidation. How you are defining primary consolidation, secondary consolidation? The reduction in volume of soil which is due to squeezing out of water from voids is called primary consolidation. तो प्राइमरी कंसोलिडेशन क्या है? रिडक्शन इन वॉल्यूम ऑफ सॉइल, जितनी सॉइल है उसका वॉल्यूम कम हो रहा. द रिडक्शन इन वॉल्यूम सॉइल विच इज ड्यू टू squeezing out of water from voids is called primary consolidation. The reduction of all excess hydrostatic pressure to zero, some compression of soil takes place very slow, is called secondary consolidation. So now with the help of three-phase diagram, define the following: air content, relative density, dry density, saturated density. So if you see the figure, it is air, it is water, and it is solids. So we will wait for 2 minutes. Prayer is going on. So first is air content. How you define air content? Is it defined as volume of air voids to the total volume of voids. Next, relative density. It is the ratio of difference between the voids ratio of cohesionless soil in its loosest state and existing natural state to the difference between its voids ratio in the loosest and densest state. क्या है air content? It is defined as volume of air voids to the total volume of voids. So we need to define with the help of this diagram, define the following: air content, relative density, dry density, and saturated density. So how we are defining air content? So what is air content? It is defined as volume of air voids to the total volume of voids. That is, volume of air is VA, volume of voids is VV. So air content AC is equal to VA by VV. Next is the relative density. So how we are defining relative density? It is the ratio of difference between the voids ratio of a cohesion-less soil in its loosest state and existing natural state to the difference between its voids ratio in the loosest and densest state. So how we are defining relative density? It is the ratio of difference between voids ratio of a cohesion-less soil E minus in its loosest state and existing natural state E minus E max to the difference between its voice ratio in the loosest and densest state. E max minus E. So what is next? Dry density. So how we are defining dry density? The dry density is the mass of solids per unit of total volume before drying. So what is gamma D? Rho D. Dry density of soil. Dry density of the soil is the mass of solids per unit of total volume. Mass of solids per unit of total volume of the soil mass. Next, saturated density. It is defined as the ratio of total soil mass of saturated sample to its total volume. What is saturated density? It is defined as ratio of total soil mass. Total soil mass of saturated samples to its total volume. With usual notation, prove that SE equal to WG or gamma T is equal to 1 minus theta into G gamma W divided by 1 plus WG. So here SE is equal to WG or E is equal to WG by SR, degree of saturation. So your E into SR equal to WG. So for fully saturated soil, SR is equal to 1 and W saturated is equal to water content and saturation. So your E is equal to VV by VS. VV by VS is how much? W into SR divided by G gamma W. So your G is equal to WS by VS into gamma W, or VS is equal to W into SR by G gamma W. So your E is equal to G into VV by WS into WW by VW, where WW by VW is gamma W. And your E is equal to G into VV by VW into WW by WS, or WW by WS is water content W, VW by V is S, degree of saturation. So your E is equal to WG by S, or S is equal to WG. Then gamma d is equal to 1 minus neta A into G gamma W divided by 1 plus WG. From three-phase diagram, V is equal to VA plus VW plus VS. So dividing throughout by V. V by V, VA by V, VW by V, VS by V. So VA by V is neta A, or 1 equal to neta A plus VW by V plus VS by V, or 1 minus neta is equal to VW by V plus VS by V, or 1 minus neta is equal to WW by gamma W into V plus WS by G gamma W by V, or G is equal to WS by gamma S into gamma W, VS is equal to WS by G gamma W, or VW equal to WW by gamma W, or W is equal to WW by WS, or WW is equal to W into S. 1 minus neta is equal to W into WS gamma W by V plus WS G gamma W by V. Gamma D is weight of dry soil by V equal to weight of dry soil is weight of air plus weight of solids by V. So weight of air is 0, so it is Ws by V. Now substituting gamma D value in equation 1. 1 minus theta equal to W into gamma D by gamma W plus gamma D by G gamma W. So 1 minus theta equal to G W into gamma D plus gamma D divided by G gamma W. So it comes out to be gamma D 1 plus omega G WG divided by G gamma W, or 1 minus theta into G into gamma D is equal to gamma D 1 plus omega no WG. Therefore, gamma D is equal to 1 minus theta A G gamma W divided by 1 plus WG. In its natural condition, a soil sample has a mass of 22.9 Newton and a volume of 1.15 into 10 raised to minus 3 meter cube. After being completely dried in the oven sample weighing 20.35 Newton, find the bulk density, water content, voids ratio, degree of saturation, air content, dry density, and percentage air voids. So, what is happening in its natural condition is soil sample has a mass of 22.9 Newton and a volume of 1.15 to 10 raised to minus 3 meter cube. After being completely dried in the oven sample weigh 20.35 Newton. Find bulk density, water content, voids ratio, degree of saturation, percentage air voids. So mass of soil in its natural condition M is equal to 22.9 Newton. So convert this into kilonewton, it will be 0.0229 kilonewton. So mass of dry soil equal to 20.35 Newton, or MD is equal to 0.0203 kilonewton. Volume is given by 1.15 to 10 raised to minus 3 meter cube. So now assuming specific gravity is equal to 2.7, the bulk density gamma B equal to M by V 0.0229 divided by 1.15 to 10 raised to minus 3. The gamma B is equal to 19.9130 kilonewton per meter cube. So water content is given by M minus water content is given by W equal to M minus MD by MD. M is 0.0229 minus 0.0203 by 0.0203. So W comes out to be 0.128 or 12.807%. Dry density gamma D equal to gamma B by 1 plus W. So it comes out to be 17.6533 kilonewton per meter cube. So the Watts ratio E is equal to G gamma W by gamma D minus 1. 2.7 into 9.8 divided by 17.6533 minus 1 is equal to 0.4988. So the degree of saturation SR is equal to WG by E, or SR is equal to 0.128 into 2.7 divided by 0.498. It comes out to be 69.28%. Air content AC is equal to 1 minus S, 1 minus 0.6928. It comes out to be 0.3072 or 30.72%. So finally, the percentage of air voids is 1 minus neta I equal to 19.644 divided by 17.65. It comes out to be 0.1127. I hope you have understood the topic and solved the numerical problems. If you have any doubt, you can write to me at email nadim@k1.university, or you can post it in the comment box also. So I'm ending the meeting now.